Hello everyone, welcome back to the DSA series. Today we will learn about what is a queue. A queue is a linear data structure that follows the FIFO principle. The FIFO principle, which is first in, first out. So that essentially means that the first item added is the first one removed. Right? You can also think of it as the last item that was added will be the last item that gets removed. So that would be essentially lie low, which would be the last element that goes in, would be the last item or element that would come out. Alright, so here's a real world analogy. You guys can think of a line at a bank or fast food restaurant. The first person in the line is the first one that gets served. Here are the key operations of a queue. So a queue has these three basic operations: enqueue, dequeue, and peak. So enqueue means we add an element to the end, right? Dequeue means we remove an element or value from the front of the queue. So think of a line. We have a line of persons, right? We dequeue, meaning we take the first person out of the line. We enqueue means we add a person into the line, or basically at the end of the line. Peak means we look at who is the first person in the line. So that is what enqueue and the dequeue and the peak operation does. So here are the key properties. The first added means it's the first one that gets removed, and also the last one that gets added means it will be the last thing that gets removed, right? So it's the same thing with the line analogy. The last person in the line will be the last one that comes out. And here's another thing, only the front and rear are accessed. So front will essentially be the front of the line. Rear means it will be the end of the line. And the queue data structure, guys, it can be implemented using arrays or linked lists. Now here's the time complexity of a queue for each of these operations. So enqueue, so O of 1, it would be O of 1 time complexity. We're not going to get into dynamic arrays and all of that for now. Dequeue, O of 1 time complexity, so constant time. Peak, O of 1 time complexity. Here are some use cases: CPU task scheduling, print queues, customer service system. So the print queues, guys, think of your printer. You want to print like maybe 10 documents, right? Each time you do that, you try to print one of those documents. It has to go in a particular order. So that's why we use a queue for that. And here's the summary, guys. So a queue works like a line of people. The earliest entry leaves first. Great for handling tasks and buffering systems. So what's next, guys? In the next video, we will learn about hash tables. So thank you guys for watching, and I'll see you in the next video.